My question for today is that how do we calculate the time taken for the sum of the money to double?
All right. Zwele, how do we calculate the time taken for the sum of money to double? I'll see that.
Wow, that's a very good question, Maraza. How do we, how long does it take for a sum of money to double? Amanda puts some money in the bank and she wants to know how long will it take to double. Isn't that beautiful? You put your money in the bank, leave it, and your money doubles. How long will it take? Let's have a look at an example quickly. Okay, this is a classical exam question. Matrix, you better be watching. They're going to ask you this. Now remember in earlier years, you learned the compound interest formula or simple interest. Remember A is P, 1 plus IN? Remember those things? I give it to you on the formula sheet. But the thing is, guys, what you don't know is, or didn't know, is how to calculate N, the time involved when you had compound interest. Remember that funny N at the top there? Bit of a problem. Now have a look at this. I'm going to show you how easy this is. We're going to go back to grade 10, revise a little bit, and then we'll take it to matric. Calculate how long it would take for an investment of 9,000 Rand to double. So if you double 9,000, what do you get? 18. That's pretty cool. Imagine you start with 9,000 and it doubles. That's what you want. They always say, you must make your money work for you, and that's important. Okay, and the simple interest rate is 11% per annum. Okay, so we want to see how it works. Who recognizes that formula? Do you recognize that, guys? Absolutely. And P would be what, if you look at it carefully, that's the 9,000, that's the present value. And what is A? The accumulated amount. You see, you guys are good. And the interest rate, remember, always divide the 11. Hey, look at this. I don't even need to be here. These guys are pretty cool. Hey, what a pleasure. Okay, that's excellent, guys. Now look at this, 0.11n. Okay, so if we divide both sides by the 9,000, then obviously you get 2 is equal to 1 plus 0.11n. Do you agree you can't add those? You can't add those two. Unlike terms. Okay, but you can take the 1 across, and 2 minus 1 gives you 1. Okay, and then you've got 1 equals 0.11n. So what do we now do?
Divide.
Hey, I tell you, these guys are good.
Yeah.
They should be up here. I can tell they'll do a better job than me. Okay, now look at this. If you divide both sides, it will take you approximately about 9 years for your money to double. Now, if you think about it, that's not too good because it's simple interest. Albert Einstein said, one of the greatest forces in the universe is exponential growth or compounding. It's amazing. And this is where we want to go. Now, here comes the matric work. So let's have a look here. Let's look at what Tumi is doing. He invests. He's got 200,000 Rand. He's not going to spend it on his girlfriend. He's going to be wise, and he's going to stay in the friend zone. He's not going to get involved with women and this kind of thing, because you know what it's like? You know, he wants to spoil her. So with 200,000, I mean, you can really spoil your girlfriend. Okay, seriously. So what he's going to do is he's going to invest this. Okay, he puts it at 14%. That's a pretty good, in interest rate. You know, I always tell students, when you invest money, look at things like the share market. Don't just put your money under the bed or put it in the bank. Look at other options. I wish we could do on Galezanati investing in the share market and teach students how to invest. But anyway, 14% per annum, let's suppose he goes into the share market and he gets 14%, which is 0.14. Okay, per annum, compounded annually. How long will it take for the investment to double? Okay, so the formula for compound interest, there we go. You got it there. That's pretty cool. It's A is equal to P, 1 plus I to the exponent N. Okay. Now, what are we going to do? Well, let's see. 200,000 Rand, he wants to double his money. Okay. The interest rate is 14%, but as some Piwe pointed out, you must divide by 100. Okay. So it's 0.14. All right, now we've got this. Now these two you can add together, so no problem. So if we add that, 1.14 to the exponent N you got it equal to 400. So now what do we do now? We simply divide both sides by the 200,000. Now look at this. Now the magic starts. What are we going to use?
Logarithm.
Yeah. There was a rapper inside of it. We're going to do the logarithm. Okay, we're going to do some really good financial maths. Now watch how magical logarithms is in the real world. Do you recall that from last week's lesson? The log of 2 to base 1,14. You see, this guy 1,14 is in the friend zone. There's an exponent n. N is a high and mighty. She says, I don't like you 1,14. You too base for me. You must get down. And she kicks him, and he goes right down there, and he sort of, there's a log there, and it's log base, log 2, base 1,14. He sits there, he's very dejected, he's in a low position, he's feeling depressed. Okay, all right, so we got it. And once you got that, now watch this. Isn't this cool? You simply use your calculator. If you look at the Casio calculator, it's got log, square, and a little square. You push that button, you remember that one, and you plug in the values. You put in 2 and 1,14, and there you go. Let me show you quickly how this works. If you don't know where the button is, have a look here. It looks like this on the calculator. Log. There we go. Okay, and once you put the 2 into there, and into there you go 1,14, and you push equals. And look what it does. It does this for you, and it'll tell you how long it'll take for your money to double at the interest rate of 14%. Okay, now look at that. This is not too bad. It's 5 comma something. Okay, now if you take the decimal 0.290058556, you take that decimal, you multiply by 12, that will give you the number of months. So Amanda, check this out. It will take approximately 5 years and 3 months for the money to double at an interest rate. Okay, so there you've got it there. Can you see how important this is? What a pleasure. And there you go. Okay, so that's great. Now, another situation where we can do it is depreciation. Do you know, guys, when you buy a new car, and you drive out of the shop, that car immediately depreciates. It gets less in value. Isn't that tragic? That's why, be careful with cars. They're very much liabilities. People think it's, you drive a zooty car and a funky car. Here we go, wow. It's going to cost you a lot of money. I always say to people, save up cash. If you can save up cash for a car, you can negotiate. You see what I mean? And this is the secret. But now let me show you what happens. If you've got a motor car which costs 200,000, let's just go back there, depreciates at 8%, it's getting its values going down. And we're going to use the reducing balance. Remember, you get the linear, and they always ask reducing balance. Calculates how long it will take for the car to depreciate to a value of 90,000 under these conditions. Okay, so who knows what the formula for depreciation is? Let's see if some P-Way can.
Well, it's A is equal to P, open bracket, 1 minus I, close bracket, to the exponent of N.
Hallelujah. There
Hallelujah.
Amanda. There's a God. Somebody knows financial maths. I am impressed with you. You from which school?
Bedford View High School.
Oh my word. I want to develop a friendship zone with your teacher. I tell you, she's good. Okay. I want to get in the friend zone. Your teachers are teaching you well. That is beautiful mathematics. Oh, this makes a maths teacher like the Sangoma very happy. Yes, now look at this. All right, now what do? We start off with the 200,000. Now remember, it started at 200,000. It depreciates to 90. It's getting less. What things depreciate? Cars depreciate in value, like that. But you know what's amazing is, like, if you think of gold coins, if you could buy a gold coin, or if you could like have some paintings that are sometimes, if you think of some paintings that over the years, I mean, you take the Mona Lisa, if you look at that painting, how it appreciates in value. And if you invest in like gold coin, if you put your money into a correct investment, it appreciates in value. It gets more. Your money makes money. This is the thing. It's scary. About 5% of South Africans will be able to retire independent. And this is what we want to do on Galeza Nati, show you to invest money. Don't go and spend all your money. If Tumi went and blew the 200,000, that's terrible. But he can make his money work for him. You see that there? This is the power. But now watch the car. If you look at how long it's going to depreciate, it was at 200, goes to 90,000, and it's an 8% on the reducing balance. Now that's the formula for reducing balance. It's kind of like compound interest, but it's reducing on a compounding scale. Okay, so look at that. So it's 1 minus 0.08, which gives us, what is that, 0.92 in the brackets. Divide both sides. What's 90,000 divided by 200,000 is 0.45. Now look at the power of the logarithms. Put the log in, And I'll just finish this and then we can carry on with the show. Okay, now look at that. It gives you about 9,57. If you multiply the decimal by that, you get 9 years and 7 months.
My question for today is, what happens when the compounding periods are not annual and you have to calculate the value of n?
Awuzwele, what happens when the compounding periods are not annual and you have to calculate the value of n? Please help us out with that one.
Whoa, that's a typical matric exam question. Watch out for this, guys. When the compounding period is not annual, that would be monthly, half-yearly, quarterly. Let's have a look at this one. So take notes. They could ask this. You see, how long will it take for an amount of 150,000 Rand to double? That's easy. If the interest rate is 18% per annum, compounded monthly, what do you do to the I?
You divide by 12.
And what do you do to the N?
Multiply by 12.
Now listen, these guys from this school are really got it taped. Listen, you divide I by 12 and multiply N by 12, but we don't have N. So what do? Have a look at this. Look at this. This is so important. There's actually two methods you can do. So you divide your 0,18 by 12, but don't forget, whatever N is, you times by 12. N is years, so if you times by 12, you get months. So we're working in months. Now check this out. Very simple. 0,18 over 12 is 0,015, and then we simply add up those two numbers in the brackets. And then if we divide both sides by the 150,000, we land up with 2. And guess what comes to the rescue? The logarithm. Okay, so here we go. So we can then say, okay, fine, no problem. Let's introduce the log. Remember, 1,015 is in the friend zone with 12n, and she doesn't like him. She's too high and mighty. Yeah. Okay, so she kicks him down, and he goes to the other side, very depressed there. Look at that. So it's log 2 to base 1,015. Okay, now if you work that out in a calculator, 12n is then 46. Now what is that? 46 months. Okay, now if you want it in years, what do? Divide both sides by 12. So it gives you 3,87, okay, which would be 11 years, which would be, that's about 11, or 3 and 3 months. Okay. Okay, so the other side that you can do is, if you look at this, if you treat n like that, okay, then what we do there is we simply go and do this. Okay, so 2 equals 1,05 to the n, and now we're working in years. Okay, all right, so there we go. Or that will give you n, which is 46 months, or it could be 3,8 years. Okay, if you work that out with that thing, the n would be months, because you then, if you work it out, that would be the number of months, assuming it to be months, then you divide by 12 to give you the number of years. You see the difference there? So you get 46, so you can either do 12n or you can do n as you wish. Okay, cool.